So here I've got a quick video that just shows you how you're going to locate these images and lenses. Again, if you haven't tried the assignment yet, please try the assignment because it is so much more valuable for you to find these yourselves than to just memorize it. So in the first case, we had our object was actually beyond 2F. So our object was beyond 2F. We were able to use all three rules to locate my image. So my first rule, I went in parallel and I came out through F. My second rule is I'm going to go in through F, my secondary principal focus, and I'm going to come out parallel. And my third rule, I'm going to go straight through the optical center. I can see that all three lines are going to go ahead and cross at this point here, so I'm going to draw on my image. For salt, if I compare my image to my object, my image is smaller, my image is inverted. The location I would say is between F and 2F, and this would be considered to be a real image. In a lens, a real image is anything that's on the opposite side of your object. Before I go on, you'll notice that salt here is actually the same for mirrors. So if you were going to look at the salt for an object beyond C in a mirror, you're actually going to see the same salt. So it's going to be the exact same thing for lenses. Now we're going to look at an image where we're at 2F. We're going to use the same three rules. So we're going to go in parallel. We're going to come out through F. We're going to go in through F. We're going to come out parallel. And then we're going to go straight through the optical center. You can see that all three of these lines meet at the same point. And here's my image. If I go through and describe my image, I would say this image is actually the same size as my object. It's inverted. It's at 2F, and again, because it's on the opposite side of the object, it's considered to be real. I'm going to move my object closer now, and I'm going to look at an object between 2F and F. Again, I'm going to go ahead and I'm going to draw a line in parallel. That line that goes in parallel is going to come out through F. My second line, I'm going to draw in through my secondary principal axis. That's going to come out parallel. And my third line I'm going to draw is going to go, again, straight through my optical center. I can see all three lines are going to meet here, and I'm going to go ahead and draw in quite a large image. You can see it kind of stretches off the screen here. This image here is considered to be larger than my object. It's still inverted, it's beyond 2F, and it's considered to be real. I'm going to move my object closer again, and I'm going to go ahead and I'm going to go right through F. If you notice, I can actually only draw two lines here. I'm not able to draw my line going through F because I'm actually on F, right? So there's no way that I could take a ruler, line it up at the top of my object, and go through F as well too. So this one, I can only use my two rules. My first rule is I'm going to go in parallel, and I'm going to come out through F. My second rule is I'm going to go straight through the optical center. You're going to see here that both of these lines are going to run parallel. If these lines run parallel, that means they're never going to meet. If these lines never meet, then we're not considered to have an image. So if you're able to put your object directly in front of your focal point for your object in your lens, you're actually going to see no image. So if you can actually line it up that your object is on F for your lens, no image is going to appear through the lens. We're going to move closer again, and when we move closer again, we're now before F. So before F, again, I can't use that second rule of going through F, so I'm limited to two rules. My first rule, I go in parallel, and I come out through F. My second rule, I'm going to go straight through the optical center. Now here you're noticing that these two lines are actually moving away from each other. If these two lines are moving away from each other, but not running parallel, that means that they're never going to meet on this side. But it does give you the clue that they are going to meet on this side. So notice that this line stays not dotted, it stays solid. That's because this line actually exists. This is an actual light source that's going through and passing through the optical center. However, this emergent ray, I'm going to draw a dotted line back. Now remember, this is an apparent light source, so I use that dotted line because it doesn't actually exist on this side of the lens. They're going to cross here, and if I draw in my image, I'm going to notice that it's larger, it's upright, it's on the same side as the object, and since it's on the same side as the object, it's considered to be virtual. Your last one that I gave you was your diverging lens. Now, diverging lenses, again, form very, very, very similar images. So we only did one in this case. So here I've got my object. My first line, I'm going in parallel and I'm going to come out through F. Now remember, I'm not going to bend towards F, I'm going to bend away from F. So I'm going to go ahead and I'm going to diverge. And if you take a ruler and you line this ruler up, it's diverging as if it was traveling through F. So this line, this emergent ray, actually exists, so it's solid. This line here is just an apparent light source, so we drew it dotted. My second rule, I went in through F. So again, if you take a ruler and you line up this line here and you let it keep going, it's going to look exactly like it's traveling through F. However, instead of going all the way through F, as soon as I hit the lens, I'm going to bend. And how am I going to bend? I'm going to bend parallel. So that's going to cause an apparent light source on this side. So I used my dotted line to trace back an apparent light source on this side, going back, and it's parallel to the principal axis. Finally, my third rule, I'm going to go straight through the optical center. In this case, it is a real light source. It does happen, so we use a solid line. We can see nothing's going to cross on this side because it's diverging, but on this side, we can see that one of my actual light rays and two of my apparent light rays are going to cross here. This is going to be my image. So in a diverging lens, my image is going to look smaller. It's going to be upright. It's going to be on the same side as the object, and since it's on the same side of the object, it's considered to be virtual.